Hello students, welcome to your second chapter solutions. Let's see introduction. Solution means the homogeneous mixture of solute and solvent. Here we come across a few new words which are actually learned in your school level 9th class. Solute, solvent and the homogeneous. Homogeneous means simply getting mixed throughout, and a solute comparatively which is lesser in quantity, and the solvent is comparatively larger in quantity. Their composition is nothing but solution. Let's suppose a beaker, take some water in it, which is our solvent, and a pinch of salt is added. Stir it well. Stir means mix. So after stirring, you'll get a uniform solution, uniform mixture, which can be called a solution. Now a mixture, if it is uniform, it is nothing but the solution. Now it is called salt solution, which is a homogeneous mixture. You can have another review by listening to the definitions and look at the text. So a solution means, students, it need not be always a solid in liquid. So it can be, as you can see in the picture, it can be of many types. It must be uniform, that's all. Homogeneous. So the combinations may be, you can go through this text which is also in your textbook. So these many kinds of solution which we will discuss later. Now let us see dilute solutions and concentrated solutions. Based on the relative amount of solute and solvent, the solution which has more solute is concentrated, and the one which less solute is dilute. But we require not this aspect, we require a quantitative expression. That means numerically, mathematically, we require some expressions which is nothing but the concentration of the solute. In the solution, the solute is expressed in terms of concentration. So here we see what is concentration. The amount of solute present in the given amount of solvent is called concentration. Some methods to express concentration are listed below: mass percentage, volume percentage, mass by volume percentage, mole fraction, molarity, normality, parts per million. So out of these you might have come across few in your first year. Just as we express length in meters, weight in kilograms, etc., the concentration can be expressed in these many ways. So let us see the methods one by one. First one, mass percentage. Percentage means, students, simply when it is made up to 100, which is measured to 100, is nothing but the percentage. The mass of solute in grams present in 100 grams of solution is called the mass percentage. This also you learned in school level. It's very simple. And the below one is its symbol. You can solve some numerical problems also later based on mass percentage. Simply the mass will be given in some random numericals, and the total mass of solution will be given in some random numericals. Simply you make it to 100 and tell the percentage. That's all. That is mass percentage. Similarly, next we have the volume percentage. Here all the components are taken in volumes. So the volume of a solute in milliliters present in 100 ml of solution is called the volume percentage. Simply the down one is its symbol. Much important topics are given later. These are just definitions, and these you'll get for 2 marks in your IPE exams. Next comes one more important expression for concentration, that is mole fraction. The ratio of number of moles of one component to the number of moles of all the components in the solution is called the mole fraction. As you already know from maths, a ratio, fraction is simply nothing but a ratio which is written in the form of a by b, and divided we'll get some value. So mole fraction means simply moles by moles. So to calculate we have 2 steps. First, finding the number of moles of the given components. So after finding the moles individually, just substitute the data and take their ratio. So example, calculate the mole fraction of 4 grams of NaOH, 4 grams of sodium hydroxide dissolved in 36 grams of water. So let us calculate this by using data. So you may not see here because of my name. X is a symbol for mole fraction. The formula N1 by N1 plus N2. So if there are I number of components, ith component moles by the total mole sigma Ni, that is a formula. So let's take the step 1. As you know, the molecular weights which were already learned in the school level and even in your first year. Right, N of NaOH, sodium hydroxide moles, weight by molecular weight. You substitute 4 by 40, you will get 1 by 10, that is 0.1. Then after that, moles of water. This is also in the first step. So after solving, you will get 2 moles. Then in the step 2, take their ratios. So means 0.1 moles and 2 mole. Those are the moles, number of moles of individual components. Then in the next step, take their ratio, number of moles of NaOH by number of moles of NaOH and water addition. So in the right side, you can see the solution. After simplification, the answer you get for number of moles, mole fraction of NaOH as the given value, that is 0.047. So the remaining also are done here, you can see. Remember children, sum means addition. Sum of mole fractions of all the components, not only 2. How many components there may be? Sum of mole fractions of all the components is equal to 1. That means here there are 2. X1 plus X2 will always be equal to 1. That means any mole fraction is individually is always less than 1. That is, X1 is less than 1, X2 is less than 1, and X1 plus X2 is always 1. Thank you for watching. I'll meet you with my next video. Hope you understand.